All right, we've all seen an AI do something simple, like answer a basic question. But how does it jump from that to tackling a big, complex project with multiple steps? Well, today, we're going to pull back the curtain on the framework that makes all that possible. Let's get into it.
And really, this is the core question, right? It's the central challenge for developers. Asking an AI, hey, what's the capital of France? That's easy. But what if you ask it to, say, research the economic impact of tourism in Paris, then summarize your findings, and oh, by the way, draft a blog post about it? Whoa, that's a whole different ballgame. So how do you teach a machine to follow a plan like that?
And that leads us straight into what you could call the complexity conundrum. It's this fundamental problem we have to crack if we want to build AI applications that are truly powerful and, actually useful.
It's as simple as that. A basic request is just a one-and-done deal. But a complex project, that's a whole sequence of tasks where every single step relies on the one that came right before it. If you don't have a clear structure for that, you just get chaos, a total mess.
So, to solve this puzzle, developers took a page from a classic playbook. They drew inspiration from something we all understand, a system that's been perfected over a century for managing incredible complexity, the assembly line.
I mean, think about it. You don't build a car by just throwing a bunch of parts in a room and hoping for the best, right? That would be absolute madness. You need a very specific, highly organized system to handle it all.
An assembly line works because it has these very distinct stations. First, you build the frame. Done. Then, that completed frame moves down the line to the next station, where the engine gets installed. From there, it goes to get painted, and so on and so on. Each step is its own self-contained job, all happening in a perfectly logical order. That's how you tackle a massive undertaking. You break it into simple, repeatable steps.
And in the world of software and AI, this exact concept has a name. It's called a pipeline, and it's basically an assembly line, but for information. The output from one step, like our car frame, becomes the direct input for the very next step. It's a simple idea, but it's absolutely the key to taming digital complexity. Now, every good assembly line needs a foreman, right? Someone to manage the whole workflow, make sure everything is running like clockwork. Well, for AI, that foreman is an open-source framework called LangChain. You can think of it as the orchestrator, the one who organizes all the tools and makes sure the entire process just works.
So before, building a complex AI felt like trying to untangle a giant ball of yarn. It was this one huge monolithic block of code where a single tiny error could bring the whole thing crashing down. But the LangChain way? It's modular, it's organized. Each step is like its own separate replaceable Lego brick. So if the paint station suddenly has a problem, you can just fix that one part without having to shut down the entire factory. It brings beautiful, simple order to all the chaos.
Okay, so that's the theory. But what does one of these pipelines actually look like when it's doing its thing? Let's walk through how an AI might use this to build a real response to a query completely from scratch.
Okay, let's take that big, complex research question from before. In a LangChain pipeline, the user's question is the first input. That query gets passed to the first station, a web searcher. The search results that come back are then handed off to the next station, a summarizer. Then, that raw summary gets passed to a language refiner to get polished up, and finally, that clean, polished answer is delivered back to the user. See? Every single step is its own module, all connected together in a seamless chain.
So, you might be thinking, okay, that's a neat way to organize things. But this shift from a tangled mess to a clean pipeline is way more than just a clever trick. It's a fundamental, absolute game changer for how we build AI. So why is it such a big deal?
Well, the power here is just immense. Let's break it down. Modularity, that means you can swap out a search tool for a different one just like changing a Lego brick. Reusability, that summarizer tool you built can be used in dozens of other AI apps you create. Clarity means anyone on a development team can look at it and see exactly how it works. Scalability lets you just keep adding more steps to tackle even bigger, more complex problems. And the big one for developers, debugging becomes so much simpler. If the final answer is weird, you can check each station on the line and pinpoint exactly where things went wrong.
And that's really the bottom line. This entire pipeline approach, orchestrated by tools like LangChain, is what's letting developers finally move beyond simple little chatbots. It is the framework that's unlocking the creation of truly sophisticated AI, ones that can research, write, analyze, and follow through on complex plans in a way that's fast, smart, and most importantly, manageable.
So this leaves us with a really fascinating thought to end on. This isn't just about writing cleaner code. It's about unlocking new capabilities. By teaching AI how to follow a plan, we're opening up a whole new frontier of automation. The question isn't really if AI can handle these complex projects anymore. It's which complex projects are we going to hand over to it next? What do you think? Thanks for joining us on The Explainer.